Hello, my name is Caden Bunch, and this is my presentation on the impacts of cystic fibrosis on the pulmonary tissues of sheep. So some of y'all may know growing up in Utah that it's quite the close-knit community in which that some of y'all may even share the same grandparents. And although this is great for social experiences, it's not so great when it comes down to these genetic diseases such as cystic fibrosis. So cystic fibrosis is a recessive human genetic disease characterized by mutations in the cystic fibrosis transmembrane conductance regular or CFTR gene. And what happens when there's mutations in this genes is it causes kind of thickening of mucus in the lungs and intestines and kind of all over the body. So although there are 2,000 mutations of cystic fibrosis that are known, the F508del and G542X tend to be the most common, with the other ones kind of ranging in severity. So what we've kind of seen is a lot of research is focused on kind of the post effects, like when the person's alive or when the animal model's alive, what's happening. However, what we realized is that when babies are born with cystic fibrosis, they have a lot of health defects and a lot of things that make life hard for them, even starting out. So what we wanted to see is we wanted to see at what stages of development was this happening. And you can't really do that work on a baby. You got to do it using an animal model. And that's what we did here. We used sheep. We prepared these sheep with cystic fibrosis, and then we collected tissues at key times of development in the fetal growth periods, particularly in the lungs. And these were at days 50, 65, 80, 100, and 120. We kind of see that on the figure on that right in that chart. So we can kind of see here in the results what it kind of looked like. We have all these pulmonary airways that are forming. We can see at the 50-day, they're kind of more segregated and identifiable. And then kind of later on at 80, we see more of these airways getting larger and thicker, as you might imagine with lungs developing in a baby. However, what was surprising is the difference between the wild type and the cystic fibrosis sheep. And we see that in this top right. We see that around day 80 is when we see the drastic change, where the cystic fibrosis had a large filling of liquid inside the lungs and smaller airways. So what we found is that at these key points, it's likely that the cystic fibrosis, although not the main cause in this developmental pathway, is hindering and impacting this development. And our hope is that using this research and other research, we can find the key points at when an infant can receive gene therapy to help correct any defects that can form. Thank you.